Hello coders, welcome to another How to Code Well podcast. It is episode 205 and today we've got another explainer podcast where I explain a certain topic and today's topic is DVCS. Can you guess what that could be? So version control systems, that's the topic that we're going to explain today. And this, like last week, is totally live. And like last week, what I'm going to do is, this is live, it should be public. And once the podcast is finished, I'm going to just allow this for the members, and then this will be released as an audio podcast in about probably 3 weeks' time. So it is the 19th of October 2024 at the moment. So, it's going to be a few weeks before this goes out, but that's how I'm going to try the schedule at the minute. Also, as this is live, you may hear some dog noises behind me. We've got 2 English Springer Spaniels, so they may get a bit noisy, and if so, I may have to duck out. But all of those things hopefully will be not in the audio version. Before we start talking about the DVCS systems, let's do a little bit of a change log. There's been a couple of things that have happened in the last time I've spoken, so last week, regarding How to Code Well. So on howtocodewell.net, we have updated the Linux Bash for Beginners course all the way up to tutorial 12. I've added code samples and documentation. There's, I believe, 15 tutorials in there, so I've got about 3 more to document, and I'm going to try and do at least one a week. So that's going on strong. I've also done a deployment to the site this week. I did that early in the week. We had some changes to the user interface to just make things a little bit more easier on the eyes. There is a ton of other improvements that I wanted to do. That's going to happen in the future. There was a couple of bug fixes. There was a lot to do with proxy changes that I did, because all of this is containers at the background. So I probably know a lot more about proxying in Nginx than I probably should do. But it's been fun. It's been totally fun. And I can say that going forward, we are going to have some tutorials that are going to be based on Laravel. So if you are interested in learning a little bit more on Laravel, then please do sign up. Go to howtocodewell.net and click on the join button and create yourself an account, and they will be coming your way in hopefully a few weeks' time. But by the time the audio comes out, they're probably already going to be on the site. Okay, so all of that stuff is done. Let's now dive into the actual explainer. Today we're going to be focusing on DVCS. Excuse me. DVCS. Now, you might think that D means digital because that's what we do, but it's actually distributed version control systems. We're going to be talking about those, and we're going to be talking about centralized version control systems as well. I'm going to be reading from an article that I'm going to apply to this podcast when it goes on to the howtocode.net website in about 3 weeks' time. So here we go. We're going to start from the top. Code storage, code share. Oh, hang on a minute. Have I? Yeah, I've skipped this out. Okay, so I've skipped a bit out. Let's start again with the DVCS explainer. Okay, so version control systems. Code storage, code sharing, code revisions, and code collaboration is the topic for today's explainer. Programmers usually store their code in a distributed version control system, DVCS, that's what the acronym is, which allows them to share, track, and collaborate with other programmers who are working on the same project. So the next part, what is a DVCS? A distributed version control system is a tool that allows programmers to commit changes to a code repository that is accessible by other developers. A repository stores historical code changes which can be fetched, reverted, merged, reviewed, and compared. Okay, so now we're going to start talking about the remote part of a repository in terms of a DVCS. So we're going to pick on Git in this case. So each developer will have a local copy of the whole repository, which allows them to work in isolation. In Git, the remote repository, which is also referred to as the origin, is the name of the remote repository in which commits are published to, where the code is cloned from, and where the code changes are fetched. So, before we go any further, so when you create a GitHub repository, a repository in GitHub, when you type in on your command line git remote add, when you're adding a remote, you are adding the first remote you add is the origin. And that would typically be your GitHub repository. That's the URL of where the repository is stored. And so when you do git push origin and then whatever the branch is called, which we'll talk about in a minute, then you're pushing to that origin, to that remote repository. The keywords there are remote and origin, because when we get to the centralized stuff, it's a little different, but that's yet to come. Okay, so when it is time to integrate code changes back to the origin, the developer will fetch any new changes held by the origin, fix any conflicts locally, and push their code to the origin when ready. Key there is that when you're dealing with DVCSs, so Git for instance, when you apply or when you fix code conflicts, you do that locally. You don't do that on the remote, on the repository. You do that on your own local copy of the repository. Now, I mentioned branch there, so let's talk about what branches are. Okay, so code is typically stored in a DVCS via a series of branches. This is also true for centralized ones too. These are isolated streams of code that can hold a new feature, a bug fix, a code experiment, code yet to be released, or the stable code that is currently running on production. So, for example, if you wanted to do a little investigation, maybe you're tasked with a spike, and that spike is to investigate how one would apply a certain, I don't know, a fix or add a new feature or change a package, something like that. Something that doesn't really have a defined end goal because it's an experiment. Then what you would do is you would create a branch for that experiment, for that spike, and then you would work within that. It means that you're working in isolation. It doesn't mean that you're tinkering with the stable code. The stable code should be protected. It should be kept away from any experiments, and we should be using continual integration to ensure that the code that we want to integrate into the stable line of code, and we'll talk about the various different streams of code in a minute. When you want to integrate it, you use continual integration, which is a series of basically gatekeepers that say, hey, this code doesn't comply with these standards, or hey, this code doesn't is failing these tests, right? Or hey, this linting isn't great, or hey, we haven't done this, hey, we haven't done that. It goes through a series of these gates that check various things on the code before it can get integrated into the mainline. Okay, I'm using words that I haven't even explained yet, mainline and all that jazz. Okay, so I'll go through that again. Code is typically stored in a DVCS via a series of branches. This is also true for centralized version control systems. These are isolated streams of code that could hold a new feature, a bug fix, a code experiment, code yet to be released, or the stable code that is currently running in production. So when we're fixing a bug, we might be doing that as a hot fix. That would be a branch that is very sort of quick and temporary. That would fix the issue, and then we would apply that, merge that back into whatever the stable stream of code is. If we were to do a feature branch, then yes, we would create a feature branch that perhaps me and other developers are working on to build this feature out. Maybe we need a front-end dev, maybe we need a back-end dev, maybe we need a dev that knows a bit of the database, whatever. And we're all working on that. And then maybe we have our own branches that feed off of that branch. Maybe that is, say, a bulk branch, for instance, where the front-end guy is doing work that doesn't have to interfere with the back-end stuff, and then it all comes together and it gets merged into this one branch, which then, when is ready, gets integrated into the stable line of branch. Okay, so I'm getting ahead of myself here. A way to think of these branches, going back to the documentation, a way to think of these branches is to imagine a series of train tracks that branch off from each other. A track will be connected to other tracks, making a network of connections. So imagine you've got like a single line, which is the stable, and then off of the stable track, you then have other tracks that come off of that, and maybe other tracks that come off of that track as well. And they get eventually folded into each other until the branch that comes off of the stable line wants to integrate back into the stable branch. That's when all the code checks and everything happen. Okay, so that is how perhaps one should look at the Git and distributed version control systems. So another way to visualize code branches is to think of these as a tree structure. So each branch will originate from a tree trunk, and as the tree grows, other branches will sprout from the trunk, or other branches as well. The original track is sometimes referred to as stable or mainline, as I mentioned, main, as this branch of the code holds the stable code that is running in production. Okay, or you may not have even pushed to production yet, but this is the code that you're going to push to production. So maybe you're a startup, maybe you haven't even deployed the first release yet, but you need something that is quote unquote stable that other feature branches can then integrate into. So these two examples, you've got the tree example and you've got the train tracks example, they are great until you start talking about where they fall short. So going back to the article here, where these fall short is when we start talking about integrating the branches. Usually this operation causes the feature branch to be removed after it has been successfully been integrated. And now I've completely lost my place because I looked away. let me start that again. Where these examples fall short is when we start talking about integrating branches. Usually this operation causes the feature branch to be removed after it has been successfully integrated into the main branch. Branches should also be short-lived. Some only last a few minutes, like literally if it's a hot fix, you want to just get it done, fix it quickly. Whilst others could last much longer. And, hot fixes are slightly different because there's testing involved and everything. Not saying that there's no testing in other things. Perhaps there's less testing in the experimental stuff in terms of strict testing to get it into the main line. Usually when you start dealing with spikes, what you do is you create a POC, a proof of concept, and then off of the back of that, you're able to then update the ticket to make it a little bit more defined, and then from that you create an actual branch, a feature branch, off of what you've decided based on the spike, if there's any work there at all. But the point here is that branches should they should be temporary. You've got to think of them, apart from the stable line, of course, the branches should be temporary. So you do your feature branch, you merge that in, there is no need to have that branch in existence anymore. You just take it away, you remove it. You remove it both from your local machine Also, you remove it from the repository itself, from origin. But with Git, the brilliant thing with Git is that, well, the brilliant thing with distributed version control systems is that everybody has a copy of the repository, everybody has a copy of the history, and branches that were once deleted can also be brought back to life, be recovered, because what the repository is storing, and I'm going off piste here because I haven't even written this in the article yet, maybe I need to update it, but what the repository is storing is the changes between the code. Okay, it's storing the history of the code, and that requires knowledge of the user, when the change was made, what has been removed, what has been added, that kind of stuff. And the mind-blowingness around Git is the fact that because it's distributed, everybody has their own local copy of not only the code but also the history behind it. This is where things start falling short when we start talking about CVS, but we haven't got that to that stage yet. I am getting ahead of myself again. Okay. Each branch, going back to the documentation here, each branch will hold the history or historical information that came before it and knowledge of what code has been committed since the branch was created. Code history will include the author, the code change, what code has been added, replaced, or removed, as well as a message from the author which explains the reason for the code change. And we can go into a whole podcast episode, if you wish, on how to actually write a decent commit message. And I will put both of my hands up and say, I do it wrong. I kind of know the right way to do it, but I don't do it. It becomes a bit of a, you have to be disciplined, because when you're just saying adding new files or, I don't know, fixed a bug, it's not giving the other developers who read the historical changes any kind of justification as to why that change was made. So there is a better way of writing these messages. And at the end of the day, Git and a distributed version control system is almost like a historical record. It is a historical record of what code changes has happened before, and you should be able to look through the logs and actually understand why the code has got to the place it is at the minute and why these changes have come in. But if you're just seeing history where it's just adding files or fixed bug or trying this again, then you've got no context as to why that change was made. So yeah. Okay, so now we get on to the next part, which is what is a CVS? A CVS, a centralized version control system. Because if you've got a distributed version control system, as I've mentioned, everybody has a copy of the code and the code's history on their local machine. That is not what a CVS is. A CVS is a centralized version control system. A CVS is a single centralized code repository which stores every version of that code. It is a single server that you and the rest of your development team access and pull code from and push code to. You do not have the historical information on your local version that you would with Git. That's all stored on the server. That's also managed on the server as well, I should say. So developers pull changes from the server and work on their branches locally. When it's time to push changes to the repository, any conflicts are resolved on the server. However, when you're pulling changes down from, say, SVN, for instance, and you're putting them into your local branch, then you may have conflicts on your local branch. You then may have conflicts when you push that up too. Subversion, Microsoft Team Foundation Server are examples of centralized version control systems. I have used them both. Okay, so the next part, now we've understood what a a centralized version control system is and a distributed version control system is. Let's pit them to each other. So the next section here is DVCS versus CVS. So the main difference between a distributed version control system and a centralized version control system is the way the code is shared to the developers. With a distributed version control system, each developer has a copy of the full repository that they can work on locally. This is different to a CVS, where a developer is tethered to a centralized repository. This leads to advantages and disadvantages of using the code repositories. So they both have disadvantages and advantages. Okay. So the first one is a single point of failure. A CVS, a centralized version control system, has a single server that holds the repository. If this server goes down, then no one can work on the code and push changes. This will mean that the entire project team will come to a total standstill. That happens and has happened to me before, and it is very infuriating when the server that is holding the SVN repo is either being overloaded or has other things on the server that really shouldn't be on the server. It should actually be a separate server. This has happened to me before. And it's like, well, why are we doing this? Because that thing that is also on this server is causing this server to slow down, which means that it's taking me a long, long time to get to the latest changes and deal with any conflicts coming my way. And of course, if you've got a team of a decent amount of people and it goes to a standstill, then that's a lot of developers who can't do any work, which is annoying. Unlike a CVS, developers who use a distributed version control system will have a local copy of the code and its history, which means there are many distributed backups of the code base, which can be worked on even when the origin is offline. Because you've got a backup, essentially, with Git of the repository. When you clone origin, you are cloning the whole entire repo and the history up to that point, which means that if GitHub goes down, yes, you can't push to GitHub. Yes, you can't fetch any new stuff to GitHub, but nobody can push anything either. But you can still create branches. You can still create various different changes and merge changes and pull changes from one branch to the other and do all sorts of crazy rebase things on your local machine, ready for when that server comes back online, when GitHub comes back online, and off you go. But also, it means that you can take your repository and then use that as origin, right? So if you wanted to, you could take your GitHub repository and create another repository that isn't on GitHub, but is a Git repository, and then you could use that as origin. Also, I don't want to totally confuse everybody, but you can have more than one remote. So I've done this a lot where I've had to push code to various different places, right? So what you have, and maybe this works when you've got say like a single project that has many different so let's say you've got a single project and that project has many different repositories in there, right? So maybe you've got many different remotes, you see? Yeah, so I've done that before. That was quite fun. So you push one to say GitHub, another one to GitLab, another one to Bitbucket, that kind of jazz. So this is fully distributed. So not only is it distributed from the point of everybody has a local copy, but you could also have multiple places where you actually push the same code to, the same branch to. Okay, learning curve. Moving from a CVS to a DVCS is a steep learning curve. Hell yes it is. Because the developer needs to consider that there is no longer a single repository server that everyone pushes code changes to. There is now many repositories that are held locally, and commands that can be ran against the origin can also be ran against their local working copy. And that, when I started learning, and I'll talk about my past, I think, because I think that's quite relevant. So when I started as a developer, I worked on FTP. That was basically what I was doing, right? I was FTPing files up and down, left, right, and center. And we would get into a bit of awkwardness when we've got two developers working on the same thing. That would be a problem. And then came along SVN, and I started working in a bigger team, and we started using and they were using SVN. To me, that seemed incredibly logical, fantastic. Yet there were all of these problems that did crop up when the server went down, or there were troubles with delays because we were waiting. You basically had queued up branches ready to be sort of merged in. Everybody had to deal with conflicts and everything like that. So it was a bit sluggish, it was a bit slow. Sometimes it did take a long time to actually get your code integrated and up. And then came along Git. Now, I was in that era where we were debating whether Git was actually going to be the new kid on the block, whether it was actually worth learning, or whether we should just ignore it and continue with SVN. And this point that I'm making here about the learning curve was ginormous, utterly ginormous. Because when you're using, say, SVN or Microsoft Team Foundation Server, when you've got, when you're working against a trunk, when you're working against a single repository, and you know that is what is on the server, then that's just, the friction there is low, because you know that your branches can get pushed up to there. That's where all the code's stored. Everybody's a winner. But when you start talking about everybody can do merging and branching and see the history and create new things and all of that in Git, when everybody's got a distributed version control system and they can do the same commands that one could do on the on Origin, and then when you start talking about having multiple places to push code to, that becomes utterly mind-blowing. Utterly mind-blowing. And then your whole working structure changes, your workflow, because with Git, you now have things like Git flow, where we have, say, main and develop and other branches off of that. Your whole deployment changes because you're now creating perhaps release branches. Everything just completely changed when we went to Git. But I don't regret it for a second. It's been fantastic, and Git is a tool that every modern day developer now will be using, and I'm so pleased that we are at where we are, because there were so many issues with SVN. There are certain issues with Git, sure. The learning curve is huge. There's so much about Git that I don't actually fully understand. I do wish that with Git, maybe there was some better ways maybe there should be some better ways to actually search through the logs. There are a lot of GUIs out there, which is great, but I tend to use the command line a lot, and it gets a little bit tricky when you're dealing with code hashes and all of this jazz. If there was perhaps a better way, command line interface, to search through messages, branches, and whatnot. I know that GitHub have their own sort of wrapper around Git, which I've used before, which is pretty good. But the learning curve of learning a distributed version control system is sky high if you've come from SVN. Actually, it's sky high if you're just going to Git without the need of SVN. But just know that we were using centralized version control systems back in the day. And there are still, to this day, plugins, specifically, I don't know, there's WordPress plugins I'm aware of, Drupal modules that I'm aware of, and other things that use SVN too. So it's not like nobody uses SVN anymore. So perhaps if you are used to Git, the learning curve going backwards would be even more difficult. I don't know. Also, we have another part here which I want to talk about, which is speed. So going back to the documentation, a CVS, so a centralized version control system, works well if the development team is small, as clear communication is needed so other developers are informed when code is changed, right? When the code is changed, the developer will need to pull down the changes into their branch. If this doesn't happen regularly, then there is a high risk of code conflicts. So one thing I can remember with back in the old SVN days is when someone went on holiday and nobody took over the branch, then that branch would become what we classed as stale, which meant that when the person came back from holiday, if there was a lot of change to the code during that person's vacation, then that person who's come back from vacation would basically spend half the day trying to get their code base back to where it should be. And if they're dealing with a feature branch that has a lot of changes that touch a lot of things, and then there have been many branches that have happened during that person's holiday that have also touched those things, then that becomes painful. And I actually remember sitting down with developers after they've come back from a holiday, discussing with them all of these changes that were in play. Oh, we need to, you need to update this, you need to update that. And there was a lot of recoding that needed to happen, especially when these big changes, big changes happened. But also the fact that we're dealing with a single repository here, which means, as I mentioned before, that repository, that server could get overloaded, and you end up with like a queue of branches that need to go through an order to resolve their conflicts. So when the code is changed, the developer will need to pull down the changes into their branch. If this doesn't happen regularly, then there is a high risk of code conflicts. When multiple developers work on the same piece of code, it can be difficult to find a stable moment to integrate the code changes. Yeah. Developers must communicate with the server each time they need to request a change. This can become a bottleneck as the server needs to handle many requests at once. A developer may be waiting, I've spelt that wrong, a developer may be waiting for a stable time to push their branch to the repository, but may also require changes made in another branch. This can lead to a queue of code branches that are waiting to be merged into the repo. And then also a point that I want to make here is that when you push code to the repository using, say, SVN, then you're changing you're updating the conflicts, or you're fixing the conflicts on the server. You're not doing it locally, which is one of the massive benefits of Git, is when you're dealing with conflicts, you're dealing with them locally. You're not dealing with them on GitHub, you're dealing with them locally. In fact, you cannot push code to GitHub that is in a conflicted state. You must pull down the branch, fix the conflict, and then push it out. It's not going to accept it. Whereas with SVN, it's like you're dealing with it right here. And I remember the nervousness I would get when I pressed the the commit button, to resolve the conflicts, because it was like, there we go. All of that's changed now. Everybody can pull down the changes, and I'm just going to hide under my desk because I'm sure I've broken somebody's work. Yes. So those were the good old days with SVN. I mean, like I said, SVN's still around, and it serves a purpose. But I do feel like when the development team gets to a certain stage, size, I should say, then that gets quite awkward and quite difficult. Yeah, so that is what I wanted to talk about with DVCSs. I was going to go into more depth around pull requests and merge requests and the differences between those. I was going to talk about branching strategies, the difference between what a hotfix is and what a release is. I was going to talk about tagging. Tagging's also in SVN as well, and all of that jazz. But then I just thought, well, maybe I should do another explainer video specifically on that, because the differences between a merge request and a pull request is very specific to distributed version control systems, but it's actually a very different way of working and how you set up your repository, and that needs more in-depth discussion. And every project I've worked on, and I've worked on many projects, I've been a developer for about 24 years, and I've worked on many, many, many projects, and every project is set up very differently, is deployed incredibly differently, and uses parts of Git flow, the full Git flow, a hacked version of Git flow. So yeah, it's not really like a one size fits all. When you read the Git flow documentation, it's not really we should do it like this. It's recommended, but in my opinion, every project is very different, has very different constraints, very different delivery times, very different ways of doing things. And especially if you're working on both the software code, but also the configuration of servers and say Kubernetes and all of that jazz, we can also start talking about differences between mono repos and single repos. So yeah, there is a lot involved here. I know last week we talked about databases, and I know that there is a lot of rabbit holes we could have gone down there. But what I'm trying to do at the minute is just lay some foundations, and then after that we'll go into a little bit more detail, specifically granular detail on certain pieces of these topics. But I hope now everybody understands what a centralized version control system is versus a distributed version control system. Like I said, what I'm going to do after this live stream, I'm going to make this members only, and then in probably 3 weeks time, maybe I will publish this. This is episode 205, and I believe we're on 203 at the minute on the podcast. But eventually this will be on howtocodewell.net/podcast, and then 205. And on that page, I'll also release this documentation as well. Anyway, I'm going to shoot off. I'm so glad the dogs didn't bark. That would have been awkward. I gave them like it was like was it like a pig's ear or something, some animal part that they were chewing on downstairs in separate rooms. That keeps them nice and quiet, but oh my god, do they stink. Anyway, that's a little bit more to Inside Baseball. I will speak to you again soon, hopefully next weekend, next Saturday. I will let everybody know by Twitter and also by Instagram, so do follow me there at howtocodewell. Happy coding, and have a fantastic weekend. Take care, everybody. See you soon. Bye.